we've taken some testimony already on just getting basically some background understanding of what PFAS is and what the concerns might be about PFAS in pesticides and packaging.
Okay, yeah. So basically, this is Hao Chen. I'm assistant professor in UVM, and my expertise is about feed and transport pollutions in the soil water system, and also how to they interact with different environmental factors. Currently, we have a project to work with PFAS contaminated soil from Maine, and they have the PFAS in their organic farm, and they're forced to like shut down the farms because PFAS pollution there from biosolid applications. And it's really like already proven, like PFAS can go to winter triticale, and then it go to the milk, go to the cheese, and go to the food chain, like food, for the food we consume. So that's just a major concern. That's the reason why they shut down the farm. And we are doing the research to see the mechanisms to control the PFAS go to the food chain. So that's our current work. So today I want to just more emphasize about PFAS is really like being proven. It can go to the plants, and that's the first step to go to our food chain, affect our like ecosystem. And also it's for the health side, they also prove like PFAS, once they go to human body, it take years to be like half-life to be degraded. So it's kind of like a cause serious exposure to humans and other like ecosystem like components. So why PFAS matters? Because PFAS is very unique. They're resistant to chemical breakdown. So the farm we mentioned in Maine, they actually applied biosolid 20 years ago, and still they're affected by PFAS. Means it lasts for 20 years, still like being like a major hazard over there. And it's extremely like resistant to break down. Microbials cannot break it down, and heat or like light cannot break it down. So it's just the reason why we call it forever chemicals. And yeah, so also PFAS by like EPA like definition, it have millions of variations. So that's something make it hard to regulate that. But we do like highlighted a subgroup of PFAS that need a lot of attention. And the major problem of PFAS come from like carbon and fluorine bond. That's one of the strongest bond we found in like chemistry. And they have a variety of salts. I think like in Vermont, we already like regulate like firefighting like foams. That's yeah, that's the major PFAS exposure to like a residential place. And here today we want to talk about pesticides related to PFAS. It's like a surfactant in pesticides, and sometimes it's from packaging. So they have like different source and different type. And biosolids is also evident a major source of PFAS that affect our agricultural land. So that's the major source of PFAS. And airport, we probably in Vermont, we also know like we have military like airport, it have heavily contaminated with PFAS. So that's some major source we already identified. So I'm just be more focused with PFAS and plant and soil since we are focused with agriculture today. And before I go dive to the PFAS like interaction with the plants, I think one thing very important to point out is PFAS have different variations. Like one is short chain PFAS we want to highlight, which means they have long chain and short chain. And this is short chain PFAS, and typically they have 4 carbons to 6 carbons, and sometimes they can have like a longer carbon chain to up to 12 carbons. So these, like we want to divide that in two groups because they have different behavior in the soil and the plant uptake behavior. And these are PFAS we want to highlight today, and this is most used for our like daily life. and also have big exposure to like populations, so have higher risks. And the PFAS in the soil, right? After PFAS go to the soil, it's forever chemicals, right? After we apply that, where it goes, and the fate really depends on PFAS self, and also depends on soil texture. And if we have soil in Vermont, we have clay soil, and if we have soil in South Carolina, they have sandy soil. PFAS gonna have a different behavior. So all those factors determine like affect PFAS fate. But overall, right, still they have two major like behavior. One is uptake by the plants, the other is go to groundwater. And the plants, we eat it. Groundwater, like rural area, we drink groundwater for drinking water. And also we use groundwater for irrigation. So both ways like cause human exposure for PFAS applications, especially to the land. And I think pesticide itself is a major like pathways to introduce those PFAS to our soil system. And yeah, those
Professor Reed, can we interrupt? We have a question here.
yeah.
Thank you, Doctor. I just, we've had some testimony on PFAS, but a new word popped up there, which was sulfuramide under pesticides. And I
Yeah.
just wondered what that was.
I think they can like change some of the already have the compound. They just replace the bond between like carbon to hydrogen to carbon to fluorine. So they can like the chemicals more stable by like replace some bond.
Would that be an active ingredient or an inert?
Yes, some is activated, like active ingredient.
Okay. And the other word,
yeah, sorry.
oh, sorry. The other word that has come up, but I don't know what good definition of it is, polymers. And I was wondering whether we were dealing with polymers here, but your last slide showed that there are two different directions you can go, whether it's polymer or non-polymer.
Yeah, I think that's a good question. Like polymer, like Teflon we use like for the like a pipe, right? It's actually a PFAS, but it's kind of like a polymer PFAS. So that's even we like consume it, probably it wouldn't go to the blood. But those like smaller molecule of PFAS that have a high chance go to the blood, go to the fat, go to like our human like organs. So that have a different toxicity levels. So that's the reason why like polymer haven't considered like a highly priority for EPA yet. That's my understanding of that.
Thank you.
Representative Lipsky, question?
Yeah, Professor, if you could go back to your last slide for a second.
Yeah, sure.
So on the extreme right, there looks like a point source discharge pipe that seems to be contaminating the groundwater.
Yes, and there's some source like pollute groundwater for sure.
But what is that discharging?
I would say like the
Mhm.
wastewater treatment plant, some of the PFAS they are not treated there, and also I think it also relate to education. Like some, they don't understand PFAS is pollution, so they just dump PFAS to the to the nature land.
Right. I mean, it seems to me that wastewater treatment never goes on the land application. It goes into waterways. But it
Yeah,
seems to indicate it's going directly to land application.
yeah, that's true. I think like yeah, that's very true. I think typically like wastewater treatment plant, they either go to the like a lagoon or something to let it digest a little bit. But what I know is a lot of people that don't consider PFAS as pollution, so they just release that and assume it's safe.
In Vermont, we don't do land application of biosolids from wastewater treatment.
Oh, that's great. Yeah, that's great to know. I was a little worried we may find the same issue as
We haven't passed, but we haven't for several years.
Yeah, that's a good point because the land we have in Maine actually they applied biosolid like 20 years ago, and the PFAS still there because it's forever chemicals.
Thank you.
Yeah, so yeah, even it happens in the past, probably we still need to be, cautious about that. So yeah, that's forever chemicals that just accumulate over time. So the other we also well documented is PFAS is go up through the food chain. And you know, like in Great Lake, they find the PFAS in the fish, they're in the top of the food chain, it's a much higher concentration than the bottom feeders. So that's PFAS accumulation through the food chain, and they were biomagnified. And for example, right, we have PFAS in winter triticale, and PFAS go to the milk and go to the cheese. We will see the concentration increase by the further operations. And yeah, this is again, right? We have short chain PFAS, long chain PFAS. I just want to emphasize this again because they have very, very different behavior. And EPA define PFAS with huge varieties. But when we study its behavior, we have to cut down to small a chunk because different groups, they have different behavior. And especially for plant, we're gonna talk about today later on. So they have very different behavior when plant uptake. And also like previous slides, I showed PFAS in plants and in groundwater. Typically groundwater, most tested PFAS is short chain PFAS. And the long chain PFAS, they stay in the soil. And Maine, that organic farm, most PFAS is long chain PFAS. So that's what we observed. And they have different variety of concentrations. I think Raju in our environmental engineering department, he did a survey of PFAS in the non-contaminated land, and still we found background PFAS already, probably through the air depositions. That's my hypothesis. So, but this just to show us they have very a range of PFAS concentrations to the soil. Yeah, so PFAS can definitely being uptake by plants, and yeah, different plants they can take up PFAS from soil or water. They will move to edible part. So it's not just stuck in the roots, they can move to the leaf, move to the fruit and grains, like a winter triticale, they go to the grains. And also I think in Purdue, they found that they go to the oats, go to the barley for the PFAS. And some study in the model plants like onions shows PFAS can damage some plants. But typically we don't observe that high concentration to cause the damage to the plant itself, but definitely have accumulations. And yeah, let's have a look about some of the examples of the papers we have as evidence. So research have found PFAS can in cereals, fruits, and vegetables, they can accumulate in edible tissues. And we need to regulate that since those kind of plants, we consume that. And also give the urgency to prevent PFAS spread and improve our understanding as well. It's not just us working on this. I think public, we have to have more education about how to proper use PFAS. Yeah, so for the plant uptake in scientifically, we have two index. One is the bioaccumulation, the other is translocation. Bioaccumulation is just how much it go to the plants, and the biotranslocation just means how much from the roots can go to the shoots. Is that just stuck on the roots, or it can actually go to the shoots? I think microplastic, they have very, very low translocation from the roots to shoots, but not for PFAS. And also yeah, we're gonna have some examples with this. So this one paper we want to cite is about use different wheat, firm to uptake PFAS. They have 30-day experiment. These are very common, a firm we can find in the field. And yeah, and this is their result. the green bar here is all how much PFAS went to the shoot, which is edible part for the animals, right? So like still like most of the PFAS is still in the soil, but they do show like a slow uptake to the shoots. So that's one of the evidence. Only 30 days we found like a PFAS in the like a leaf of those like weeds, right? But definitely like PFOS is long chain PFAS, the uptake is limited. But like PFBA is short chain PFAS, they have more uptake. So like long chain and short chain, they have a different behavior. And yeah, PFAS uptake like depends strongly on the chain length. And translocation is most limited for small PFAS. So yeah, we may think, right, as long as we like regulate small PFAS, small chain PFAS, maybe we are okay. But actually in the field, the long chain PFAS, they do break down to like small chain PFAS. So still long chain PFAS is also a hazard. It will aging and break it down to be more bioaccessible for the plants. Yeah, this is actually another paper about not just the weed. Actually, it's a tree. It's a willow tree, which is also like we have it here in Vermont. They did an experiment with the hydroponic studies, and those willows can uptake PFAS to the leaves as well, right? And different species, they definitely have different capacity, which is definitely like a very general for like different plants. They have different capacity to uptake those PFAS. And still very similar trend. So for the like leaf, most short chain PFAS and long chain PFAS, they don't go up. They just stay in the bottom, in the roots, and in the like systems. So that's very consistent with the weed and also with the tree like species. Uptake most for short chain PFAS. Yeah, so short chain means carbon is less than 7, right? 7 like a carbon like a chain length. So they have good accumulation to the leaves. All the experiment done is in the short term. So we expect with time increase, we probably gonna observe more PFAS go to the leaves. And yeah, last evidence is about herbaceous like fern. Like they also tested those like chemical PFAS. These are non like polymer PFAS. And they found the similar trend, right? So most of those like shoot accumulate more PFAS and the root accumulate like relatively less. And the other thing here we want to, yeah. So these are like similar evidence here. So yeah. So last example we want to like show is actually mustard, hemp, and sunflower. It's more like agriculture, like crops here. And they did experiment with PFAS uptake and yeah, with different treatment. Here, I don't want to go to all different treatment. We just want to like show, right? So these like a sunflower here and mustard in the middle and hemp in the last. And we can observe we do have high like PFAS accumulate in the leaf systems and less PFAS in the root. And all those plants, we consume those plants, right? So that's definitely another examples about how PFAS can go to our food chains, like through those edible like plants. And actually, most of those PFAS go to the leafy part of the mustard we actually gonna to consume. And leaves have the highest PFAS for our like testings, and mustard have the highest PFAS concentrations. Different plants that do have different capacity. There right now, like a lot of research are going on about to identify which plants may be more resistant to PFAS uptake. But yeah, they have some general rules as well. Like short chain PFAS, definitely like dominant to the leaves and the stem. Most long chain PFAS, they just stuck in the roots. Like if we eat potato, definitely gonna to peel the skins, gonna help a lot to eliminate those PFAS. But for the leaf, actually it's inside of the plants. So yeah, if those soil are impacted by PFAS, probably there's some PFAS in the mustard leaves. Yeah, so in general, we want to all those research done is very recent and have done in very high impact journals, and we cited here today. And our experiment done with the winter triticale still undergo analysis. Yeah, so probably we're gonna share that when we get to result. And the PFAS movement in the plants definitely controlled by many factors, right? For PFAS itself, like chain length matters a lot. And probably that's important for our regulation, perspective. And also roots matters. Like winter triticale, we tested have fine roots, it have higher uptake for the PFAS. And also it's transfers. And the PFAS, sometimes if concentration is too high, it also hurts plants. Probably that's the reason why it's sometimes can be ingredient for the pesticides. So yeah, that's the overall I want to prove evidence about PFAS can definitely uptake from the soil to the plants, and then it will enter the food chain, affect our health. Yeah, thanks.
All right, thank you. We have more questions, I think. Representative O'Brien.
Yes, Professor, one thing I was wondering about, if there's any research done, like in our committee, we did a lot of work on neonicotinoids. So I was wondering if there's any research done in PFAS moving through plants, through budding and flowers, to pollen and nectar, and how that might be affecting invertebrates.
Oh, that's actually I did not follow, but I can do some literature review about that.
Okay, yeah, and right, I mean, it's even things like, what was the expression? I don't know if anybody remembers, glutation. There's when little tiny bits of water do come off plants, a lot of invertebrates use that as a water source, so they could also be getting a lot of PFAS that way too, I suppose.
Yeah, that's a good point. I haven't followed those kind of research yet, but definitely I can do some search about that to see if we have some evidence about that's a way to spread PFAS to the ecosystem.
And one last thing was that, Vermont now is almost 80% forested. So
Yes.
given that our forests are taking up PFAS, it seems like a state like Vermont has this enormous, we talk about a carbon sink, our forests being a carbon sink, but they're also being a sink for PFAS then too, right? Because they're forever sort of encased in our trees.
Possible. I would say it's possible because one of the experiment I showed today is actually for the willow trees. Do feels like based on their data, looks like PFAS does go to the forest, to go to the leaves. Probably, yeah, we can definitely look into that. Yeah, so that's the thing. PFAS, that's forever chemicals. Even when the leaf fall and decayed, the PFAS still there.
Other questions? Representative Nelson.
Yeah, Professor, have you ever? I'm familiar with the site in Maine to an extent. And we know that came from the spreading of sludge and a lot of it was from paper mills. There was no herbicide or pesticides applied there, it was an organic farm. But PFAS concentrations in rainwater. Is there measurable PFAS in rainwater?
In rainwater, I actually don't think so. But I think in groundwater, we did test the PFAS. So I think, yeah, we work with Department of Environment. So in Vermont, they kind of have groundwater data that's affected by PFAS. Rainwater, probably it's a little bit hard to, oh, you mean directly from the air?
Yeah.
Even have it, I doubt the concentration is measurable because it's kind of like a tiny bit of that. We have a limitations about instrument. We have to have the concentration have to be reach certain threshold for us to detect that with our chemistry instrument. So I would I would say we probably should have the PFAS in the air. So when we have the rain, should be washed down. I think in North Carolina, they did a research about like some of us have a hairband. They just use that hairband to collect, you know, the track human like movement for a week. They test how much PFAS in that hairband, and they tested quite amount of PFAS, probably collected from the air.
Well, like acid rain, you're talking.
Yeah,
We,
rainwater should have it.
uh, we took some testimony last week on on pesticides that the EPA has approved. Pesticides containing PFAS that the EPA has approved. And I don't think at the time, I don't think we heard anything about short chain or long chain. We did hear about single fluorinated compounds. Do I remember? Do I have that correct? In any case, I don't know whether this falls within your area of expertise or not, but I'm wondering if you have any knowledge of whether those EPA approved pesticides containing PFAS are long chain or short chain.
Yeah, I think they approved the PFAS, not typical PFAS, like they just pesticides, they replace one bond with fluorine to make it more like last longer, have longer shelf life. That's my understanding of that. And the long chain PFAS and short chain PFAS is like a common PFAS for our industrial use, not like pesticides, I would say, because that's that's a different. I would say one thing about PFAS regulation is that's just so much variety. We cannot just give one like draw a line to say, hey, PFAS is good or bad, because there's so much different variety. And the polymer PFAS probably is okay for us to like for Typholon. Yeah, but short chain PFAS we did find a high bioaccumulation. And I'm not particularly familiar with pesticides like that chain replace of the fluorine bond, but I can look into that. I think here we don't have too much research with that yet. Yeah, but I definitely can look into that specific compounds that EPA approved.
If you have the time and the means to do that and are able to share that, we would be appreciative.
Yeah, definitely. I can like look into that. I will share my like findings with Patricia.
Thank you.
Did we hear it was some of the longer chain, right, ones that the EPA has already banned? Or banned from pesticides, maybe like your
So
North Bennington.
the PFOA, PFOS, Gen X, those are all long chain.
Gen X is short chain. PFOA and PFOS are long chain. That most used for like packaging and also surface coating for non-stick or like waterproof, and also sometimes used as surfactant. I think for these kind of like use for pesticides should be regulated. I don't think it can easily find a substitute. And yeah, I'm not an expert about pesticides itself, but I would say like just for packaging, it's not that necessary.
Thank you.
Yeah, we have different like plastic bottles, doesn't have PFAS, it just works fine.
Other questions?
Just a comment, that Dr. Breyer, professor, we had a toxicologist last week twice, and there's a lot of similarity to the testimony, and Dr. Breyer had diagrams of the shorter
Mhm.
and the longer. There weren't three categories, but there were clearly arranged. And it's really great, Jared, for our committee to get this kind of testimony.
Yeah, I'm just
Our knowledge.
Yeah, I do think PFAS, they make it too broad definition, make a regulation really hard. If they have, more like a smaller group, probably it's easier for us to say, hey, this should be like, we can have that. But right now, PFAS have millions of variety. How we, to just draw a line there is really hard.
Right, thank you for that observation, and I don't see any other questions. Anybody have any other questions before we let Professor Chen go back to?
Do you remember what was when PFAS started breaking down, there was it wasn't, I'm not even sure it was PFAS, but it was a smaller
Yeah,
molecular thing that potentially also had problems. Yeah, it was something, and it's like,
TFA or TDA?
are you familiar with that, Professor?
I'm not.
Okay,
Yeah, we most work with PFOA, PFOS, and its precursors.
Yeah, TFAs.
TFAs, okay.
TFAs. So I guess when some of these chains break down, a piece
Yes,
moves off called a TFA. And
I see. Yeah, I see. Yeah, it's kind of like the long chain like slowly break down to short chain and then they become bioavailable. And long chain is less bioavailable. Like microplastic, we found it's less go to the shoes and less go to our, it's just leave our system with digestion, systems. But those PFAS, it do go to blood and go to our like, organs. So that's the reason why it cause way much higher concerns for these type of PFAS.
Well, yeah, I think this has been helpful to understand that if to the extent that PFAS or anything else is moving into a plant, it may not get past the roots and into leaves, but even in the roots, if we're eating the roots, potatoes, carrots, that's something to be aware of.
Really.
Yeah, we need to peel the skins for sure.
Okay,
or plants die, right? And then it goes somewhere.
yes, yeah. Very good, all right.
Absolutely.
Well, thank you for making time for us this morning. We appreciate it.
Yeah, sure. I really like, yeah, I think it's really important, not just for academia or regulations, also for public awareness. A lot of people, we still not sure about like PFAS and how serious the issue is.
Thank you.
Good,
Thank you.
thank you.
Yeah, thanks. Yeah, bye.
All right, take care.
Yeah.
All right, we can go off live.